Hi students, today topic we are going to see about temperature measurement using thermistor. In previous classes we had a discussion on the topic of RTD. So today class we are going to see about thermistor. What is that thermistor? So when you are talking about thermistor, we can just separate it into two words. The first one is called therm and resistor. So when you are coining two words, it will comes like thermally controlled resistor. So thermistor, which is nothing but a temperature controlled resistor. The resistance offered by the solid state temperature control device, it depends on the temperature, and the resistors are all temperature dependency, depends on the temperature coefficients. Generally in resistor we have two different types, either it is fixed or it is variable, and the temperature coefficient is very low such that the change in temperature does not affect your resistance value. So how the temperature coefficient of thermistor is varying based on your thermistor effect. So there is a physical change, and the physical change we used to call it is temperature. So when it is getting heated, because of the temperature, the nature of a particular device, electrical property, that is nothing but your resistance, it is also going to change. So your physical quantity is getting changed into an electrical. That is the reason thermistor, it comes into transducer. So we used to call thermistor as a temperature transducer, because the physical energy is getting converted into electrical energy. And moreover, it is made up of a semiconductor based metal oxide with metallized or sintered connecting leads onto a ceramic disc or bead. And what is the definition of this thermistor? It is like a two-terminal solid-state thermally sensitive transducer. It allows a significant change in resistance with respect to changing temperature. So you can just look at the diagram I have given. There are so many different types of thermistor models we have. So which one? This is the one, the smaller one, and these two, they are used in laboratory point of view. Not only that, for the students, if you are doing any project work, they used to go with this type of thermistors. But when you are coming for these type, these are all like an industrial devices used for measuring temperature. So generally based on the temperature coefficient, either it is increasing or decreasing, depends on the temperature effect. So it consisting of two different types. One is NTC, the another one is called the PTC. What is NTC? NTC, which is nothing but negative temperature coefficient. PTC, which is positive temperature coefficient. So whatever the different types of material we are going to use, based on that, it has been categorized, either it is NTC or PTC. So just we are going to see about what is NTC. NTC, which is negative temperature coefficient, it's a device whose resistance decreases with increasing temperature. So what will happen if there is an increasing temperature, resistance decrease. So automatically you will have a non-linear characteristics. So that is the reason why that is called negative temperature coefficient. But this has been giving a precise value and predictable decrease in resistance with increasing temperature. So what are the material they are using? How they are making the particular type of thermistor? So here when you are looking at this, they are having ceramics and polymers, and which composing of metal oxides, and they are dried and sintered to obtain a desired shape. So when you are looking at this NTC, generally the people used to go for cobalt, nickel, iron and copper oxides are preferred. So how we can find out the particular thermistor, either it is NTC or PTC when you are going to purchase. So when you are looking at the diagram on the outset, your NTC thermistor symbol based on the standard IEC, your symbol is look like this. Only thing is here it is minus T. But if you are going for positive temperature, that is PTC, instead of this minus T, the indication will be positive T degree. And you can just look at here the graph, and the graph which has been drawn between temperature and the resistance. So the temperature value they have taken both positive and negative. So for 0 degree centigrade, your value is something like 1K. Then for 150, your resistance is about 100. Then for minus 100, it's going to be 1 mega ohm. So here the type of thermistor we have used is depends on 10 to 10 mega ohm range, and the temperature is minus 200 to 400. But here you can just look at for 200 degree centigrade your value is 10. Then for 100 value it is going to be 100. So it is not proportional change, right? It is coming down. So it is going to a negative temperature curve. So you have a steep resistance temperature curve. It denotes good temperature sensitive. And this is comes like an nonlinear relationship between the resistance as well as the temperature. And for approximation, why they are going for approximation? Suppose like if you want to do this nonlinear behavior into linear characteristics, then the people used to go for linear approximation techniques. So there are two types of approximation techniques we have in general. So comes to PTC. PTC, it is positive temperature coefficient, and the resistance, whose resistance increase, the temperature is also increased. So automatically you will have a positive. So it is linear graph. And here the types also depends on the material. So in PTC also, the first one is based on the silicon. You are having linear. Second one they are calling as switching type. And according to manufacturing process, the PTC belongs to second characteristics. As a switching type PTC gets heated, the resistance start to decrease up to a certain critical. You can just look at the symbol over here. Just compare PTC with your NTC. Only thing is in the downwards you have plus 3 degree centigrade. And here you can just look at the graphical one. You are having two things. One is Thermistor. The Thermistor one you are having a linear. So there is a proportional change. But you are looking at the next graph. This is switching type PTC. This is quite sensitive to the change in temperature. And the resistance is going for, because of it is polycrystalline ceramic body. So you are having a non-linear characteristics. So the resistance starts to increase dramatically with increasing temperature. So it's going like starting from minimum, then it's going to increase, then again it comes back. So this is the type of switching type PTC. So we have in PTC there are two things, either the people used to go for Thermistor or they can go for switching type PTC. So the classification is also based on the size and the shape of thermistor, either NTC or PTC. It is all like in metallic oxides only, and the metallic oxide they will just getting into pressed into in different shapes and the sizes. If they are pressing into an bead, that is bed, it is comes like in disc or cylindrical shape. And if once pressed into bed, it is known as bed resistor. It is like a disc shape, then it is called disc. The third one is cylindrical one. So the bed, this is how the bed, that is it was pressed like this. You have two terminals, and here inside this point you have a metallic oxide. So it looks smaller in size of the leads are just look like an And here one more thing is, this particular type, the cost is very low. That is also one of the advantage the people used to go for bed type. Then how it is working? So far we are discussing, if there is a temperature change, it leads to change in resistance. But how the temperature changes are going to happen? Either it is because of external factor or due to the internal factor, the temperature get vary. So the most important internal factor is just nothing but, if the current flow through the device, then automatically what will happen? If the current is getting increase or decrease, because of that, whatever the material we are keeping inside, that will get heated. So because of that self-heating, automatically there will be a rise in temperature of the thermistor. Therefore, the resistance also increase. But how they are relating means, the expression is R is equal to R naught of e power of beta of 1 by T minus 1 by T naught. This is the total resistance. This is what I am just going to calculate it in terms of Kelvin. So this R naught is an initial resistance at a given temperature. Beta, which is nothing but this specific coefficient, because for each material it is going to get vary. And in terms of temperature coefficient of the resistance, the equation is going to define this R is equal to R naught of 1 plus alpha of T minus T naught. So this is initial, and for each position how we are going to calculate the temperature, that is what this T, and the alpha, which is nothing but your temperature coefficient of the metal usage. R naught is initial resistance. But how we are going to measure the resistance? That is using Wheatstone. In the previous class, we had a discussion on the Wheatstone. Wheatstone is consisting of 4 resistance. When these 4 resistance are going to balance, this particular meter will show balance. That means 0 condition. So if it's 0, then it is balanced. If it is not 0, then it is unbalanced situation. So the one of the arm, this is what I am just going to find out the value of resistance. That is my thermistor. So the thermistor line which is connected across these 2 points, this R1 and R2 are known resistance. This is variable 1. So by varying this point, I can make an adjustment to make my galvanometer position to 0. So before calculating the value, I have to make the particular bridge into balance. So after balance, my thermistor is getting connected. Because of that, there will be a deflection. So using potentiometer or a multimeter, if you are connecting at both these ends, automatically you can able to calculate the resistance across your these 2 points. That is how the resistance of the thermistor we can calculate it using this Wheatstone. Then what are the applications of this thermistor? Because of NTC and PTC, we are having so many applications. The thermistors are generally used, you all know, in all the houses there will be an alarm system over there in the gate side. So for that alarm also, the people used to have, because of the sensitive variation of the cumin, there is a temperature variation, we have a thermistor. And it is also kept in the mobile phone, refrigerator, hair dryer, etc. Mobile phone, refrigerator, hair dryer, they are using NTC. Then to monitoring the temperature of exhaust gas, cylinder, and maintaining the room temperature at a desired level. Then stabilizer in laser diode, photo element, it is all used for your NTC. So generally when you are talking on NTC or PTC, the types of thermistor, common application, the people used to go for NTC thermistor. So that is how the thermistor application we are just listing out. So far what are all the discussion we have, that is what is the working principle of your thermistor, how you are going to measure the resistance using thermistor, what are the 2 different types of thermistor, how your NTC and the PTCs are different based on the materials, based on the characteristic curve, and finally how the relationship between the resistance and the temperature then application